Welcome. In this video, we'll be again looking at how to solve linear equations. So the difference between these particular problems and the ones that we've looked at in the past is that we have more than one variable in our equation. So let's take a look at number one and see how we might solve it. So the first thing to note in number one is what we're actually trying to solve for. So notice in this equation we're trying to solve for r. So our goal then is to get r alone. If you haven't watched any of my videos yet on solving linear equations, it'd be best to go back and take a look at those first, because we'll be following a similar strategy when solving problems in this section. So let's take a look at how we might get r alone. Well, right now, in order to get r alone, I have to get rid of this 11. So the 11, its function is that r is being divided by 11. So in order to cancel it out, I need to undo this division. So to undo division, I'm going to use multiplication. So I've got r over 11 equals m. And again, to undo division, I have to multiply both sides by 11. So whatever I do to one side, I have to do to the other. And then notice what happens. When I multiply something by 11 and then divide by 11, well, that just means the 11s will cancel out. And all that's left is r equals 11m. Now, for some students, that seems like a very unsatisfying answer because r, we don't know what number r stands for. But the point in these problems is simply to solve the equation for r. In other words, to get it alone. And as long as we have an expression on the other side and r is alone, mission accomplished. So this is our answer. Let's take a look at number two. So in number two, our goal is to solve for a. So what I want you to try is to solve this equation for a, pause the video, and then restart it after you've given it a try. So to get a alone, again, we have to get rid of this b. And since a is being divided by b, in order to cancel out this b, we're going to have to use multiplication. So I'm just going to rewrite what we have. And in order to undo this division, I'm going to multiply both sides by b. And so if I do that, b times 17 is the same as 17b. And on the other side, well, if I'm multiplying by b and then dividing by b, the b's will cancel out, and all that's left is a. And now a is alone, so that's my answer. Alright, let's take a look at number three. So number three, my goal is to get x alone. Well, if I look at the side that x is on, that means in order to get alone, I'll have to get rid of this y. Well, that means I'm going to have to cancel out plus y, because y is being added to x. So the way to cancel out addition is to use subtraction. So I'm going to minus y from both sides. And now notice when I write the minus y on the right-hand side that I'm not lining it up with the 8. And the reason why I'm not is because 8 and y are not like terms. So I don't want to line them up. So let's see what we have left. Well, the y's will cancel and make 0. And then all that's left on the left-hand side is x. On the right-hand side, I've got 8. And then minus y will stay separate because, again, they're not like terms. And now I've accomplished my goal because x is alone, and on the other side I have an expression. Okay, try number four, pause the video, and then restart it after you've given it a try. Okay, so number four, again, our goal here is to get m alone. So in order to get m alone, we have to get rid of or cancel out this minus r. So to cancel out minus r, I'm going to add r to both sides. And if you look at my work, you'll see a problem. Do you see it? Notice how I've put the r right underneath the 5. I don't want to do that. So what I'm going to do is, instead of writing it there, I want to write the plus r so it's not lined up with the 5, because the 5 and the r are definitely not like terms. So we've got minus r plus r. Those will cancel and make 0. And then all that's left on the left-hand side is m. On the right-hand side, we've got 5 plus r. So now m is all alone. And on the right-hand side, we have an expression. So mission accomplished.